Thanks for having me here today. I'm really excited to share RethinkDB with all of you. All right, so I guess I'll get started. Today we're going to be talking about RethinkDB, database for building real-time web applications. I'm Ryan Paul. As she said, I'm a developer evangelist at RethinkDB. That's my Twitter handle there if anybody wants to follow me after the presentation. Let's start with a brief introduction to RethinkDB. It's an open source database for building real-time web applications. It uses a NoSQL model, so it stores schemaless JSON documents. It's also a distributed database that is easy to scale. So, the database itself, you can store your JSON, you can manipulate it, you can create a cluster with multiple nodes so that you can, scale up really easily. But the key feature is that it's built for real-time application development. One of the key differentiators of RethinkDB is that you can take a query that you've written and you can subscribe to it to receive change notifications. So in a traditional database, you have this like request response style model. You send a query, you get a response back, and then you do whatever you're going to do with it. There's very much like a polling kind of model. But with RethinkDB, you don't have to rely on polling in order to get changes. You can take your query and get live updates, and you can stream those updates to the front end in order to reduce the amount of plumbing that you need to create real-time experiences. So that's kind of the abstract, high-level overview. I'll get into the specifics of what that means shortly. RethinkDB has a very expressive query language. It also has some relational features like tables. So you can take documents from different tables and splice them together and do things like that. RethinkDB also has a very powerful administrative user interface with point-and-click cluster management. I'll show you that a little bit later today, but it makes it very easy to get visibility into your database cluster, see what's going on, perform ad hoc queries, get results, and manage sharding and replication without having to rely on command line tools or complex configuration systems. All right, so in RethinkDB, we have this fairly straightforward structure. Your RethinkDB cluster can have multiple databases, and then each database can have multiple tables. And then within those tables, you have documents. And so when you're inserting items into your database, the document is kind of the equivalent of what you would call a row in a SQL database. A document is like the most atomic element that you're inserting into your database. All right, so in the screenshot I have here is from our admin UI. You can kind of get a feel for that structure. We have a database called Starfleet, and we have tables called crewmen and starships. And so, for example, in that starships table, you might have a document for each ship. And here's a sample document that shows you from the crew table. It shows you what a document looks like, and it's just JSON. We have made a few minor augmentations here. You can see that the birth date field, there's an actual date, so we support dates as a native type. But aside from a few things like that, the types are all just standard JSON types. In addition to dates, we also have a special type for like geospatial things like a point. And things like that. And under the hood, all of that is also just JSON. There's like a JSON object that breaks down into, but we expose it as like a date object in the database. All right, so let's get a look at the query language so you can see how that feels. So we call our query language REQL, the RethinkDB query language. And REQL is unusual. It embeds natively into the programming language that you're using to build your application. So in a lot of like SQL databases, you'd have like your query strings that you compose, and you use string concatenation and all of that. But the SQL model of string concatenation opens up a lot of problems. It's hard to securely splice in external data, and you have all of this risk of like vulnerability and all of that, and so we kind of wanted something that was cleaner. So like Mongo, you can do your queries in JSON, and that just felt very like non-native to us. So like what we did was we wanted to make our query language like just a set of functions, right? And so it actually looks a lot like what you would get if you were to use like an ORM library or something like that. It's just a set of chained methods that take parameters. Okay, so one second here. Okay. So I talked briefly about types earlier. It's just an overview again. In our query language, you have arrays, objects, strings, numbers, booleans, null. It's standard JSON types, and then the custom types I mentioned. And this is what queries actually look like. So these are 3 separate REQL queries, and in REQL, the R is kind of like the namespace, the module where we have all of the query methods attached to. So like if you're using this in Node.js, the R is like the module that you're importing. So the first query here is just looking for all of the users whose age is greater than 30. The second example here, it's all of the users who we're taking all of their last names, we're finding all of the distinct last names, and then we're counting them. And then the last one just shows how to filter and update. So I'll kind of get into more detail here, but I wanted you to get a feel for what the query language actually looks like. So here's 3 samples. So starting with an insert operation, we have our table reference. So we've got a table called fellowship. We're going to insert all of the members of the fellowship from Lord of the Rings. So when we call insert, we're just adding new documents, and we just pass a set of JSON objects. So each of those JSON objects becomes a document in the table. Okay, so then let's say that you wanted to pull out documents that match specific criteria. You could filter on a specific property. So you notice that I've got it on 2 lines, but essentially you're just attaching .filter after the table. So filter species hobbit. We're looking for all of the records that match, where the species key has the value hobbit. So you can see in our the set of documents that we've inserted that would match Frodo and Sam, right? So then you could attach another operation after that. Say that you wanted to update it to change the species. We're going to change Hobbit to Halfling. You would just chain that .update right after, and it would perform that operation on the subset of documents that match the filter. And then, so let me actually show you that really quickly, so you can get a sense of what's going on there. So right now I'm got my command line here. I'm just going to launch RethinkDB. So here I've run this RethinkDB command that's going to create a RethinkDB database instance. And now I'm going to open a browser, and I'm going to go to localhost port 8080. Which is where we run our administrative console. So this is that admin UI that I mentioned earlier. You can get a sense of what that looks like here. We have this tool called the Data Explorer that lets you interactively perform queries. Okay, so what I'm going to do now is create that table and insert some docs into it, and you can see the actual queries running. So here's our list of tables and databases. We have a database called test with no tables in it. So let's create that fellowship table in that database. So database test, and then we're going to go table create, and we're going to call the table fellowship. Okay, and then so I'm going to click run here, and it's going to run that query. So what it did here is it changed the database configuration to add a new table. So if we go back to our tables list, you can see that we now have a table called fellowship that's ready to receive new documents. Okay, so let's insert some documents into our fellowship table. I have a snippet here that I created just to save me from having to write out all of the various character names. But here we go. We're calling the insert command on the fellowship table, and we're passing it all of these documents. So let's run that command. Now, because that query was successful, it's going to return to us the keys. These are universally unique IDs for each of the documents that we just inserted into the table. Okay, so now let's say we want to see what those documents look like. You can just run a query where you're selecting the table, and you can get back all of the documents that are in the table. So here we go. We have 9 rows because there are 9 members of the fellowship, and for each one you have the name, and you have the species. So, Pippin is a hobbit. And then you have the universal unique ID, which was generated by the database when we inserted the document. So now you can optionally specify your own unique ID for each document, or you can let the database do it for you, as we did in this case. Okay, so let's revisit those queries that I just showed you. We're going to filter for all of the documents where the species matches hobbit. Okay, so that returns 4 rows, and you can see here that it's four hobbits. We have Frodo, Sam, Merry, and Pippin. Okay, now if we wanted to change that species from hobbit to halfling, all we have to do is chain an update command with the right parameters. So we're going to change species to halfling. Right. What update does is it will update the documents that are selected with filter here, and it'll modify the properties or apply new properties. Okay, so we're going to change hobbit to halfling. Oop. Did I make a mistake here? Oh, there we go. I must have typoed. Okay, so basically it's saying that it has replaced 4 documents with new versions of those documents that reflect the update that we performed. Okay, so now let's view the whole table again, and we'll see that operation was performed. So now all of those hobbits say species halfling. And so one of the great things about Requel is that the chaining gives you a really fluent, expressive way of performing these operations. So I chained that update operation after filter, which made it so that the update was performed on all of the documents that were selected by filter. But say that I wanted to add something to every row in the table or every document in the table, I could chain that update command right here after the table command, and it will perform it on everything in the table. So you can do all kinds of filtering or whatever, and you can modify subsets and things like that. All right, so that should give you a little bit of a sense of what you can do with Requel. So I showed you the filter and update commands. So now you can also perform delete. Like say you wanted to remove Boromir from the fellowship. All you have to do is chain .delete after that filter instead of update. So let's do that in the browser really quickly so you can see that. We're going to use filter on the name key to find Boromir. So there's the Boromir document. And now let's say we're going to delete him. Run. Okay, so now we get this back saying that one document has been deleted. So now if we look at our fellowship table, it has 8 rows because Boromir is gone. Okay, so the Requel query language has a lot of commands. You can do a lot of things with it. It's very expressive. If you've ever worked with, say LINQ in C# or with like RxJS or something like that, then I think that this chaining API should be kind of familiar to you. we use a lot of the similar kinds of operations. So the general categories of recall commands, we have transformations. You can map, you can order, you can skip. And we have aggregations where you can combine things by group. You can count the number of documents that match, some parameter. You can perform averaging or whatever. Then we have document manipulation. You can pull out a specific field. You can iterate over keys. You can look at the fields that are in one document but not another. And then, okay, our basic CRUD commands: insert, update, replace, and delete. And finally, we have some control operations for each, which lets you perform an operation on everything that's returned by a query, or a branch, which is how you would perform a conditional expression, like if you wanted to check against a certain property and modify document one way if it's one thing, or another way if it's another thing. So that's kind of the range of recall commands. There are actually more than I'm showing you in this slide. These are just the most commonly used. But if you look at our API documentation on the website, you can actually see the full set. So I'll show you really quickly the RethinkDB website. We have API docs with our documentation here with a full list of every command that's supported by the query language. And you can see it's actually quite a lot going on here. Some of our math operations and query commands for performing manipulation on date and time objects. Then geospatial for location-aware applications. So there's quite a lot. And when you kind of get a feel for what you can do with all of it, recall is very expressive and very powerful. Okay, so demo, I've been showing you the various queries in the Data Explorer. I'm going to revisit the Data Explorer here and show you some other things just to give you just a little more of a sense of what you can do with the query language. So we have this command that's a little unusual. You don't normally find this in database query language. We call it RHTTP, and it'll actually allow you to fetch remote data from some URL on the internet. So if you gave it the URL of a JSON document somewhere, you can actually pull it into the database and manipulate it. So I'm a big fan of a site called Reddit, and there's a subreddit called Aw that has cute animals. So one of the cool things about Reddit is that if you add .json to any URL, you can get back the underlying data from the underlying Reddit posts in that subreddit. So we're going to take and copy that URL with this JSON, and we're going to pull it into the database here and manipulate it. Okay, so the RHTTP command, that's all it does, is it grabs that JSON. So and now we can manipulate it in place. So these are the JSON documents for those Reddit posts. So we can reach in and grab specific data out of them. So let's slice away some of the cruft and get just the individual posts. All right, so now there are a lot of properties here. Let's pull out just a few properties that we care about. We can use a command called pluck for that. We're going to get the URL, score, and title from each of those Reddit posts. And so you can see here now we've got just those fields. Now let's sort them. We can use order by. We can do a descending order sort on the score. That way we can see the most popular or hottest post from the subreddit. And so here you go. You've got the score, the title, and the URL, and it's ordered by popularity. So you want to see one of those images from Aw, we can go and click the URL, and there's our puppy. It's very cute. But yeah, so you can see it's very easy to just slice and dice data. Like even if you're not using it as a database, it's just a wonderful tool for manipulating various JSON data sources. And so we're actually manipulating this in place. Every time I run this query, it's fetching this JSON. But let's say that I wanted to insert these into the database as documents. Okay, I could just do a let's say I had a Reddit table. I could just do an insert command and pass that whole query expression into the insert command, and it would insert these as documents. So you see, REQL is very composable, and it gives you a lot of really powerful tools for exploring and manipulating data. All right. Okay, so moving along, there are a bunch of other features that I'm really not going to get into in great depth today, but you can check them out in the documentation. I've mentioned a few times we have geospatial indexing. So if you're building an app that's location aware and you want to be able to perform queries like, okay, find all of the documents that have a point that's within 100 miles of Tokyo or something, you can do queries like that. We also support storing binary objects, so you can put an image thumbnail or really any other kind of like raw binary content directly into the database, and it'll store it as the value of some field. We also have date and time functions, and I just showed you HTTP command. That's the last one on the list there. So yeah, so REQL really does a lot of things. So now that you have a sense of the query language and how it works and how you can use it, let's talk briefly about change feeds, which are the features that enable real-time application development. So change feeds let you subscribe to change notifications on database queries. What that means is that you can take your query and you can say, I want to know when the output of this query changes. When any of those documents are modified or when new ones are inserted or removed. And you can do that on filtered, like full REQL queries. You can actually take some subset of the database and then look for changes on it. So the simplest example of this is that you can just tack the .changes command on the end of a table, and now anytime anything in that table changes, you're going to know about it. So say that a new user gets added or removed, you'll get an update on that query. So the changes command, it returns what we call a cursor. It's like a window into the database that you can iterate over. I'll show you later what that looks like when you're consuming it in Node.js or some other programming environment. But it's just basically like a thing that you iterate over and retrieve all of the changes from. So each time you receive an update, a change notification, it'll include the new and old value of the modified record. Okay, so say that we have a table of users and we've deleted the user Bob. The change feed output, it'll show the old value but no new value because we've removed the record. So if you were to modify Bob instead of deleting it, you would get an old val and a new val. But in this case, we've deleted it, so it only shows you the old val. So if you were to insert a new row, it would be the opposite. You would get a new val but no old val. And the output there, it's basically just JSON. And I've truncated here, but it will give you the full document for the new val and old val. So where things get really interesting is that you can chain the changes command to an actual REQL query. So let's say that you're building a leaderboard for your application. You can take your players table, you can sort it by score, and then you can take the limit command, just takes the first X number of items. So without the changes command, what this query would do is it would return the 3 players with the top 3 players by score. When you add the changes command to it, what it gives you is a change feed where you get like a window into that leaderboard, the top 3 players. And it's really very smart because when any of those 3 players, when their score changes, you'll get an update, that with the old val and new val that shows you how their score has changed. But like, let's say that you have a situation where one of your players who's not on the list, gets a massive number of points and it bumps them up into the top 3. It'll also help you with that. It'll do you'll get an old val that's the player who was there, and a new val, which is the new player who's displaced them. So when the contents, not just the values, but the actual contents and structure of your query result set changes, it'll give you updates to help you address that. So change feeds currently work with a certain subset of REQL. These are the kinds of REQL queries that you can attach change feeds to, and we're increasing this all the time. We're trying to make it so that change feeds will work with like virtually any predictable set of queries. But you can see here you can perform it on a filter operation, min, max, order by, and limit. This gives you a lot of flexibility. So I want to show you what a change feed looks like in the Data Explorer, just so you get a better sense of how that works. So let's go back to our fellowship table, we'll attach a change feed to that, so we'll do dot changes. So now in the Data Explorer here, it's waiting for things to change. So let's open a second window. We'll open the Data Explorer in a second window here. And now let's actually change something. So you might remember earlier that we changed our hobbits to halflings. Let's change that back. Let's do filter, species, halfling. So there are 4 halflings. Then we're going to perform an update where we change the species back to hobbit. Okay, now we're going to run that query. Now, what I want you to watch here is the left-hand side, because this is where we have our change feed running. So now you see on the left-hand side that it picked up the changes. We replaced 4 documents and we changed that property. And now you can see the new val, we have hobbit, and the old val, we have halfling. And it does it for all of the documents that we've modified. So when you're building a real-time application, you can use a change feed to monitor for changes to your data set, and then you can use WebSockets or whatever other mechanism you want to propagate those updates to the front end. Okay, so returning to our slide deck here. For our next step here, we're going to look at how you actually use RethinkDB in Node.js. Okay, so I hope that, because I'm speaking to JavaScript developers, that Node.js is familiar to most of you, but just a brief intro, it allows you to run server-side JavaScript applications, or build server-side JavaScript applications. So RethinkDB, when you want to use it in a programming language, you use what we call our client driver. It's a library that connects to the database and implements the REQL query language and lets you interact with the database from your programming language. So we have official drivers for Ruby, Python, and JavaScript. This slide deck is actually a little bit outdated because we just added Java as a 4th language. So now those 4 languages are all supported officially. There are also some third-party drivers from our community that add support for additional languages like Go and Clojure. So other popular languages that you might be interested in, you can check out. We'll have actually, if you want to see the list, you can go to our website and under the documentation. And you click install client drivers. Here are our 4 officially supported client drivers, and here's the list of community supported drivers. So you can see, C#, Elixir, Haskell, and these all work at varying levels of completeness. So your mileage may vary with the community supported drivers, but our officially supported drivers have full support for REQL and all of the features that the database supports. Okay, so in Node.js, you use our JavaScript client driver, and you can install that from npm and just add it to your Node.js project from the command line just by typing npm install RethinkDB. And once you've installed the client driver, you can use require to import it into your Node.js application. So what I'm showing you here is just very simple Node.js code that you would use to import the module, connect to the database, perform a query, and display the results to the console. So there's a lot going on here because so far I've really just showed you the queries, but the library itself handles database connections and all of that. So there's more complexity to it. We have an API that supports promises and conventional callbacks. So in this example I'm showing you here, we're using promises to handle the results of various operations. So let's walk through this. First, we call require to import the RethinkDB module, and we're going to assign it to the variable r. Okay, then r.connect connects to the database, and that connect method, that's where you would pass in your various settings. So if you call it like that, where it's just plain connect, then it's going to try to connect to the database running on localhost. But if you wanted to specify a host or a port, that's where you would do it as options on that connect method. All right, so next in our .then function here, we're resolving that promise on the connection. Once the connection is established, we're going to perform the query. And in this case, it's just a simple query that inserts a user named Bob into the users table. Right, and you can see that after it, we have this thing called .run. We've chained .run to the end of the query. That's how you tell the client library to execute the query. And when you call .run, you pass it the connection, which in this case is con. All right, so next we have to close the connection when the operation is complete. So I've used a .finally promise there to make it so that when the operation is complete, regardless of whether or not it's successful, it's going to close the database connection, make sure that's closed for us. All right, then to display the query's response, we chain .then. Again, that's a promise thing, and we're going to take the output and print it to the console. And the output for this query would just be that document structure that shows you the new key for the newly added document. So this is just like bare minimum code that you would use in Node.js to create a connection, insert that document, and print the output. Now, if you wanted to do error handling, you can again take advantage of the promise.error there and just add an error message at the end. In case it fails. Like, let's say, for example, you don't have a users table or something like that, you would get that error message there. Okay, so in the real world, obviously, if you're building a web application, you want to use an application server of some kind. All right, so I like Koa. You could also use Express or Hoppy or any number of other things. Koa is a Node.js framework for building web applications. It can handle URL routing, parameter parsing, and response handling. So you're building your web application, you can use Koa to define all of your routes, and you can set up queries that execute when user hits those routes. So it's very easy to use Koa to make simple REST APIs, right? All right, so here is like very simple Koa example, and it serves up rows that match certain criteria here. So remember our fellowship table, we have all of those documents, document for each member of the fellowship, and in those documents we have the species property, like our hobbits, our hobbits, and we can perform a filtered query that pulls out a specific species. So what this application does is it creates a URL endpoint where you can see a filtered view of the fellowship based on the species that you specify. So if you were to browse to /fellowship /species /hobbit, it would just show you the hobbits. So I'm going to walk you through this step by step so you understand what's going on. First, we instantiate the Koa app. We import the Koa module and call it so that we get an application. And then below that, you can see here we've got Koa router and the RethinkDB modules that we're also importing, and then we call .listen to run the application server on a specific port. Okay, now down here with router.get, we're setting up handling for a GET request, and we're doing that with the URL that we're passing into it. So what this does is it makes it so that when the user hits a URL that matches the one that we've passed into this operation here, it'll perform the anonymous function and use that to handle the request. Okay, so the anonymous function that we're passing into this get operation, you can see the asterisk there. It's a generator. Which in Koa you can use generators to simplify some of your asynchronous code. So instead of dealing with promises, we can put a yield keyword in front of the promise, and it'll resolve the output of the promise so that we can flatten it and avoid having to do .then. Okay, so we're going to start by defining a variable called con that we're going to put our connection into. So we've established our connection to the database. Okay, and then we're going to perform the query. So what we're doing here is we're calling a table fellowship. We're performing the filter operation just like I showed you in the Data Explorer. But for the thing that we're passing into the filter, the value, we're using a parameter that comes from the Koa router. So this .params.species, we're effectively taking the last segment of the path, and we're going to use that as the value that we're filtering against. So again, after /species in the URL, whatever they type, that's going to become the value that we're comparing against. So in this query, we also use .coerce_to_array. We're going to take the output and convert it to an array, and then we call .run on the connection in order to execute the query. So in Koa, if you want to return a value to the user when they perform when they go to a URL, when they perform that request, you use this .body. So we're going to take the entire output, the JSON that's outputted from this query, and we're going to assign it to this .body, which means that when the user visits the URL, they're going to get it back in their browser. And then finally, we call con.close in order to terminate the database connection. So database connections, we often get questions about connection lifecycle and what are the best practices there. There are a bunch of different ways you can do it. I tend to create a new connection for every HTTP request when I'm building a REST API. But you don't have to do that. You can actually reuse an existing connection for every request if you wanted to. Connections to the database have very low overhead, so there's no real cost to creating and destroying that connection for every HTTP request. Okay, so that's Koa here, and if you're building a REST API, that's how you would go about doing it. And then on your front end, you could use fetch or an XHR to hit that endpoint and pull in the data and then display it. So doing this kind of request response thing is very straightforward with RethinkDB, but obviously the thing that's exciting is change feeds, being able to perform query and get real-time updates and broadcast those updates to the front end. So just to show you what a change feed looks like in Node, what we're doing here is taking the fellowship table, looking for all of the changes, and then whenever a change emerges on that cursor, we're just going to display it at the console. So remember I showed you earlier how to attach that changes command to the fellowship table in the Data Explorer. This is what it looks like in Node. And again, a lot of the extra boilerplate here is just dealing with connection and promises and all of that. So I'll walk you through it. So the r.connect sets up the connection, and then .changes attaches to the change feed, and then cursor.each, you can iterate over every change. So basically what's going to happen here is this cursor just sits around, and whenever there's a new update that comes into the change feed, it'll evaluate the callback that we pass into cursor.each, which in this case is just console.log displaying received changes in the console. Okay, so now if you want to get those updates to the front end, you want to broadcast them to your users, you need to use WebSockets or some other mechanism. And so I like to use Socket.io when I'm working with Node.js. Socket.io is a powerful framework for real-time client-server communication. It has multiple different transports that it can use to perform the real-time updates, like long polling or what have you, but it'll generally use WebSockets if the user's browser supports it. But it effectively lets you send JSON messages from your application backend to your front-end client. So, if you're building your front-end application with React or Angular or whatever library you want, you can use the Socket.io client library to connect to your server, and then it'll trigger a callback every time there's a new message that gets broadcast over the WebSocket. Okay, and yeah, Socket.io, I mean, you could just use WebSockets directly, but Socket.io, in addition to supporting all these other transports, also does some really clean things for you with respect to like connection loss and things like that. So, say that you're on a mobile device and your connectivity is maybe lost here or there, like you go under a bridge or what have you. Socket.io is really good at just automatically reconnecting and making sure that that persistent connection is managed reliably without you having to do it yourself. Okay, so this is an example of how to use Socket.io in an Express application. You can use it in Express or Koa or what have you. And this is the backend Node.js code that you would use to set up a Socket.io connection and broadcast your messages. Okay, so I'm going to walk you through this. There's a bit of code here, but again, this should be pretty straightforward by now. You're going to load the Socket.io module, and you're going to instantiate the Socket.io server. You're going to wrap it around your Express or Koa instance that's listening on a port. All right, and then you're going to create this connection to the database and perform your query. Then you're going to attach a change feed to that query. So here we have .changes. In this example, it's taking the players table, it's sorting by score, it's taking the first 5. And so we've got a leaderboard with the first, the top 5 players. And every time that changes, it'll do its thing here. All right, now now that we've got that change feed, we're going to take the cursor.each, and in the callback, we're going to use io.sockets.emit. And what this does is it just broadcasts the update to all of the users on the front end who are connected over Socket.io. So every time the cursor receives a new message, it's just going to broadcast it. So now on the front end, you're building your web page and you want to be able to receive those updates. This is what it looks like on the client side. When you run Socket.io on the back end, it'll automatically create a URL endpoint where the user can load the Socket.io JS file, which is the client library, the Socket.io client library. So that's what that script tag is. All right, and then that first script tag, and then inside the second script tag, we have the code here for setting up our Socket.io connection. You just create the client connection, and then it uses like a event emitter style API. So .on update, then you have an anonymous function on the update that will just display the update to the console. Okay, so you see here the update. You see the word update. That's the handler. So in Socket.io, you can name your handlers for different kinds of broadcasts. So it's like subscribing to a specific kind of message. So you might have noticed that in our backend code, we have this word update here that's broadcasting it on this update channel, and then on the front end, we have the same word update here. So you can actually have different kinds of messages that you broadcast on different named channels, and you can have the client choose which channels it subscribes to and which ones it's monitoring for updates. All right, and so here, in this example, we're just displaying the update in the console. But like say you have an Angular app or something like that, and you're binding into some data, you can update the data structure and see that change propagate through your data bindings. Okay, so here are some additional resources that you can visit in order to get more details. I've already shown you the RethinkDB website a few times. We have some great docs on there, and this one I want to highlight. This one in particular, the cookbook. You can see this for different languages, but let's do the JavaScript one. So this is like a really useful set of docs because it'll show you common things that you're going to want to do, and it'll show you how to do them in Node.js. So I highly recommend visiting this cookbook on the website in order to get more insight into how to use Regal to perform standard operations. And then finally, we also have installation docs, which you can get to really easily from the front page. You can just click install RethinkDB. And so you can install RethinkDB on your platform. We have OS 10, which is like a DMG with a package so that you can install it really easily and then run it from the command line like I showed you today. We also have official packages for various Linux environments. So we have Debian packages for Ubuntu and Debian, and then RPM for CentOS. So if you're going to do that Ubuntu installation on your server, it's like an apt repo that you can add to your repo list. And then there are third-party packages for various other Linux environments. We even have one for Raspbian. So if you wanted to run an ARM port of RethinkDB on the Raspberry Pi, you can do that. And finally, Docker. There's an official RethinkDB repo at the Docker Hub. So you can run RethinkDB from Docker with just really simple command line command here, and it'll set it all up and run it. So yeah, RethinkDB is easy to install and get started with. You might notice that we don't have Windows here listed among our official packages. We are working on an official Windows port, and it's still kind of a work in progress. But there is a preview available of the Windows port. If you want to dig around in our GitHub, you can find our GitHub issue tracker. You can find the specific details about how to start working with it on Windows. Though I do want to caution you that the Windows port is still very experimental. We'll be supporting that officially, at some point later this year. So yeah, getting started is very easy. After you've done the installation, we have a 10-minute getting started guide that you can find in the docs. So there are a few other resources here that can take you further than what I've shown you today. So I'll leave these URLs here so you can get a look at that. Oh, so I did mention GitHub. I'll show you really quickly. If you want to see RethinkDB on GitHub, you can just go to github.com/RethinkDB, and you can click our RethinkDB repo. So we are one of the most heavily starred databases on GitHub. You can see we're over 11,000 stars now. But we do all of our development in the open. RethinkDB is open source and distributed under the AGPL license. So you can see the source code, you can check it out, you can see all of our in-progress branches, and you can participate in our issue tracker. So you can see ongoing development of new features. So like if you're looking for that Windows port, you can just type Windows here. I think this is the let's see the tag. Yeah, I think this is the Windows issue. I don't know. You can look around. You'll find our Windows build available in one of the Windows issues somewhere in there. But yeah, so all of this development is done in the open, and you can participate. We also have documentation available that describes our underlying protocol. So if you wanted to write your own third-party client driver for another programming language, you could do that too. So the other resource that I'd like to share too is that we have a Slack group. You can find that in the blog. I don't actually have a link to that offhand, but yeah, we have a public Slack group that you can join and an IRC channel. So there are various places you can go to engage with our team and ask questions and get answers and learn more. So I think that basically concludes my presentation. I'm going to take a look here and see if we've got any questions. Okay, so we have a question about dealing with other character sets. I believe that we have UTF-8 support, so you can insert other languages into the database. I know that I've done some experiments with Japanese that I think worked fine. So yeah, UTF-8 support I think is there if you wanted to use other character sets. All right. So yeah, somebody asked if there's a user group. So I already mentioned our Slack group and our IRC channel. We also have a mailing list on Google Groups. Let me see if we have I think we have a page on the site where you can find all of this. Yeah, community stuff. So yeah, here, this is actually, like, if you just click the community link, this is a great place to get all of that info. You can find our Slack community, our Google Groups. We're also on Twitter and IRC. So yeah, if you wanted to communicate with our team or with other users, these are the places you can go. We also have this cool promo where if you start using RethinkDB and you build something cool and you tell us about it, we'll send you a RethinkDB t-shirt. So you can check out our Shirts for Stories thing there if you're interested in getting a RethinkDB t-shirt. You can also see some of our upcoming events. I think it's a little outdated, but yeah, we generally put our upcoming events and conference appearances and things like that here. We have meetup groups in various places. If you're in the Bay Area, you can join us at our monthly San Francisco meetup. Yeah, you can find more about that on meetup.com. There are also meetups in various regions. There's one in Utah and a few other places. Okay, let's see. Yeah, so some people are asking about the slide deck. So if you want to get the slide deck, I'm sure the ForwardJS people will provide it, but you can also find me on SpeakerDeck, speakerdeck.com/segfault, and you can find all of my RethinkDB talks. And there's actually the training course here is a longer version of the deck that I showed you today. So that was for a really long 4-hour talk. So you can get a lot more details here with that particular deck. The deck for this talk, I'm sure the ForwardJS people will make available. I think I'll also put a copy of it in SpeakerDeck here if you wanted this specific version. Okay, let's see. Okay, so we have some questions about data reliability and things like that relative to performance and how we compare to other databases. So one of the things that's important to understand is that RethinkDB operations are only atomic within a specific document. So you can modify a single document atomically, but if you perform a query that manipulates multiple documents, that's not going to be atomic. Now, in terms of general performance and stability, the database itself is production ready. We've been developing it for 5 years, and we issued our 2.0 release last year. It was the first release that we've declared production ready, and we've had several point updates since then. So RethinkDB is stable. It is ready for production. In terms of performance and things like that, relative to data security, we tend to pick defaults that emphasize reliability over performance. So when you perform an operation, it's going to write it. There are various settings that you can tweak if you want to change durability to soft, for example, which will make it so that you can get results back before the actual update has been written to disk. So you can change those settings if you want, but by default, our standard behavior is to write to disk before we emit an update. All right, so let's see what other questions we have here. So how does RethinkDB compare to Mongo? I think that there are a few big differentiators, but I think the important thing is our support for real-time applications. The change feed feature is, I think, that like the key defining difference between RethinkDB and Mongo. Obviously, we have a lot of other differences in terms of like we have a very expressive query language and we support joins and things like that that Mongo doesn't do. And I think that there are a lot of differences in those areas as well. But I think that the real-time capabilities are the biggest difference. Okay, so we also have a question here about whether change feeds are supported on geospatial queries. And that's not supported yet, but if you look at the issue tracker, you should be able to find some discussion about that. I don't think that that's on the immediate roadmap. The things that we're currently looking at expanding change feeds to right now, we want to make it so that you can attach a change feed to like a distributed map reduce operation, things like that. So that's the next big thing that we're gonna get change feeds working with. I think geospatial is a little further out than that. That addresses that question, but you can probably find more details about that in the issue tracker. Okay, so there's a question here about hardware stats, what hardware specs we recommend if you're going to run the database. Okay, so our storage engine was originally designed with an emphasis on SSDs rather than spinning disks. So you can run it on a spinning disk, it'll work fine, but you'll get much better performance with an SSD. In terms of memory, we generally recommend at least 2 gigabytes of RAM if you're going to run it. So like, for example, if you're running it in like a 512 megabyte DigitalOcean droplet, you might have some pain. It will absolutely work in that setting, but it's not going to be ideal. We have been working on reducing the memory footprint and memory requirements. If you look at the like our last release, we had some interesting optimizations and things like that we did that that made it a little more memory efficient. Okay, so another question here, how do we handle backup and restore? Okay, so I'm going to show you real quick here. When you have the database running, you can see that I have that RethinkDB data folder. That's where things are stored on disk. You can specify a path where you want it, but all of the stuff gets stored on disk in this folder. And you can move that around, but we also have backup and restore commands that you can do from the command line to do full backup and restore. Also, obviously, it's a distributed database with clustering and replication, so you can use replication in order to to get some redundancy. But yeah, we do have command line way to do backup and restore. So you can see here RethinkDB dump, RethinkDB restore. Those are important. And you can import and export data from existing clusters. Okay, so I hope that addresses that question. So somebody wants to know a little bit more about how you do cluster administration. So I'll show you that really quickly. In our admin console, you've got our dashboard here. You can see that this graph will show you cluster performance, and you can see various information about the status of your cluster. But if you want to manipulate sharding and replication, you can click into your database here, and this will show you how many shards. And you can just click reconfigure, and you can specify how many shards and how many replicas for this specific table. So this is obviously I'm running on my local system with just one instance of RethinkDB. There's no cluster here, but if I had a cluster, you could distribute your database across that cluster. So the admin console gives you this really simple way to do that graphically. You can also do it in requel. So if you wanted to do it in requel, you could call it reconfigure on on a table fellowship reconfigure. And you can see here in our autocomplete the docs, you just specify shards and replicas. There are also ways to get more fine-grained control over sharding and replication by manipulating the configuration tables. So in RethinkDB, we have a set of pseudo tables under our RethinkDB database where you can get let's do cluster config. You can get various configuration details, or table config, probably a little more interesting. So you can get settings from our table, like here's our fellowship table, and there's sharding and replication. You can actually modify these tables, system tables, with REQL queries in order to change the settings. So if you were to change the what the value of under the shards property here, it would actually take your changes and it would apply them to the configuration of the database. So that's just a quick overview of the how you do that kind of configuration stuff through the admin console or with REQL. Any other questions?
We'll give it just a minute to see if any last minute questions come in, but while we wait for that, I just want to remind everybody that we are recording the webinar, and it will be available at Forward University over at forwardjs.com. So you check it out there. It'll take us just a little bit to get edited, but we'll get it up as soon as possible, and we will send out a tweet once it's ready, so y'all know. And then while you're at forwardjs.com, take a look at the upcoming workshops. We've got a big conference coming February 10th, so tickets are at a reduced price right now, so you should check that out because they will go up. Cool. It looks like there's a few other questions trickling in.
Okay, so we have a question about the health of RethinkDB as a company and how we're funded and things like that. So we have a team. I believe we have 18 people on our team now. We are a startup that's venture backed. We did a Series A round, so we are venture funded. We have plenty of runway and lots of interest, and we're actively building things and attracting customers. When we did our 2.0 release last year, announced it was production ready. Alongside that announcement, we also announced the availability of commercial services, and so we do have a business with customers that support our efforts, and we have plenty of runway. So we're building this for the long term, and we're very excited about where we're going. So there's another question here about what's next for the RethinkDB team. So I mentioned the Windows port. That's a really exciting thing that we're working on that you'll see coming this year. But another thing we're working on that we're also really excited about is a client-side framework. So I can't give you too many details about this yet because it's still at an early stage development, but we've had a lot of users ask us, how they can access the database from the client side without having to build their own backend. And there's a lot of demand for that. People want an experience that's more like, say Firebase, for example, where you just have a client library and you don't have to write your own backend URL route handlers or deal with Socket.io or anything. So we're working on a framework that will let you do that. It'll essentially be a Node.js application that you can just run on your server alongside the database, and then you can just have at it from the client. And you'll be hearing a lot more about that later this year. We're probably going to have a preview to show, in a few months out. So that, I think, is the next big thing that we're working on. I think that's probably our most exciting ongoing project right now. We're also working on performance always, and optimization, and more REQL commands, and making change feeds more powerful, and things like that. So we have a lot of great stuff going on, and you can get a feel for what our development priorities are by looking at milestones in our issue tracker. We generally tend to make our roadmap very public. And we tend to drive that roadmap based on feedback that we get from our users and contributors. So if you have ideas for things that you would like to see us tackle, we absolutely would love to hear them.